talk about Avogadro's number. In order to understand this, you'll want to have watched the Introduction to Moles video, as well as have a pretty good grasp of dimensional analysis. The definition of 1 mole is that it's equal to 6.022 times 10 to the 23rd atoms. And this number is called Avogadro's number. This is it. Avogadro number. Sometimes people call him avocado, but his real name is Avogadro. And this is the definition, and so we can use it as a unit conversion. What's interesting about this number is that you can have different units on it. You can have atoms if you are talking about, say, lithium by itself. But if you were talking about something else, like carbon dioxide, that's not an atom. You would need to say that you had 6.022 times 10 to the 23rd molecules. Carbon dioxide is a covalent compound, so it exists naturally in the molecule state. You might have an ion, a charged particle, like, say, sodium plus. Or you might have what's called a formula unit. And formula units go with ionic compounds. So if we had NaCl, we would say that 1 mole of NaCl equals 6.022 times 10 to the 23rd formula units. You can abbreviate this fun, as long as you don't forget the N. Then it's not so much fun after that. So let's look at an example. How many atoms of calcium are present in 3.5 moles of calcium? Well, we're keeping in the back of our mind that we know that 1 mole of calcium will equal 6.022 times 10 to the 23rd. And hey, it's just calcium all by itself. Is it an atom, a molecule, an ion, or a formula unit? Well, it's an atom all by itself, has no charge, so we know that we add atoms as units. So I'm going to start with the number that I'm given in the problem, which is 3.5 moles of calcium, and I can use Avogadro's number to convert. I've got moles up here, and so I should have moles as well in the bottom of the fraction, and then I finish Avogadro's number in the top. It's a good idea if you are not super comfortable with your calculator and super large numbers like this to practice and go along here with me to make sure that you get the same answer I do. So I'm going to put this in, and I end up with 2.1077. Checking my significant figures, I have 2 significant figures in the problem in my measurement, so only 2 significant figures in my answer. So I end up with 2.1 times 10 to the 24th, and my units are atoms, because my moles canceled. Let's look at a second example. How many moles of sodium chloride are present in 92,000 formula units of sodium chloride? We're going to start with the number that we're given, 92,000. We're going to abbreviate formula units, fun, because chemistry is fun. And I'm remembering that Avogadro's number has to do with really small stuff, and formula units are really small. So 6.022 times 10 to the 23rd formula units of NaCl are equal to 1 mole of NaCl. And on this one specifically, make sure you try this at home on your calculator, because sometimes people forget to put 6.022 times 10 to the 23rd in parentheses when they're dividing, and that means your calculator will think that it should divide by 6.022 and then it should multiply by 10 to the 23rd, and you won't get the right exponent in your answer. So 92,000, and we're going to divide, put parentheses around 6.022 times 10 to the 23rd, end my parentheses, hit equal. Should be a really small number because I'm dividing by a really enormous number. I have 2 significant figures in my measurement, so 2 in my answer, and I get 1.5 times 10 to the negative 19th moles. So hopefully you're picking up here in these problems that if we don't see atoms or molecules or formula units or ions as present in the problem in some way, either it's given to you as the measurement that you need to use or it's what you're being asked to solve for, that we wouldn't use Avogadro's number.